Hello everyone, I am Najma Nazari from the University of California, Davis. I am a member of ASIC Research Lab with the supervision of Dr. Human Homayun. This course development curriculum is funded by Intel Corporation. In this talk, we will talk about how to implement AES in software. This is the second video in a series of training modules that would explain how to design hardware accelerator using DPC++ on Intel DevCloud. Steps to writing a program. It consists of identifying what it is we know, I mean input given data, and what it is we want to obtain, I mean the outputs, results. Then we must figure out what functionality is required to map input to the output. Then for each function, we can plan solution. Two common ways of planning solution to a problem are draw a flowchart or write a pseudocode. Then express your code in a programming language. If you face error, you should detect, locate, and correct bugs, mistakes, Then run the program using test data. That we devise, we must test data carefully to make sure we test every part of program. AES is a popular cipher, a method or process used to change raw information, usually human readable, into something that cannot be read. That's called encryption. It uses a known external piece of information, key, to uniquely change the data. It is also reversible. It means it can be applied again to put the information back into its original form. That's called decryption. AES includes 3 block ciphers. AES 128, it is confidential. AES 192, it is secret. AES 256, it is top secret. It means AES 256 is the most secure and AES 128 is the fastest one. When the block size is 128 bit, it means it consists of 16 bytes and each cipher encrypts and decrypts data in blocks of 128 bits. This slide shows the overall AES design. One of the key, either 128 bits or 192 bits or 256 bits, uses as a secret key that encrypt the plain text. Plain text is information that we want to encrypt. After ciphering, we have ciphertext that we can decrypt to achieve the original data. AES is substitution-permutation network. In this network, all bits are changed in every round. First round, we XOR the current state with the first round key. Then we go through substitution layer. Then we go through permutation layer that I'll explain more in next slides. Bits are permuted and shuffled around. We do this again according to the key. For example, for 128, 10 round is needed. We do it again till we reach the final round and XOR with the last round key, and out comes the output. It should be mentioned in each step, permutation, substitution, and XOR with round key in this network must be reversible. As whole things is reversible, it would be possible to decrypt. To apply AES key, data is divided into blocks. For example, for 128 bits, it must be 4 by 4 column of 16 bytes. Example, for this phrase, buy me some potato chips, please. The matrix would be this matrix. So to chip please would normally just be added to the next block. This slide shows AES for 128 bits. AES operates on 128 bits block, which is 16 byte as a grid of 4 by 4 matrix. Each cell in the matrix contains of 1 byte. We XOR the block with the first round key and then apply the certain function that includes substitution, permutation, and etc. Then XOR with the next round key and do this process again. We do 10 times for 128 AES. Note that in the last round, mixed column step is actually missing. And finally, we XOR with the last round key and out comes the output. Always, output keeps 4 by 4 array, 16 bytes. Round key of steps come from 16 byte AES key using key expansion. So the key expansion maps from 16 byte AES key into 11 keys, each one be 16 bytes. The round function consists of XOR, byte sub, shift row, mix column, add round key. Byte sub is substitution step, and both shift row and mix column are permutation step. And finally, we added round key. The byte stub is 1 byte box containing 256 bytes table. We must apply the S-box to every byte of current state that can be implemented by lookup tables. Next step to happen is shift row, which is basically first row, nothing to do. The second row, move 1 to the left. The third row moves 2 to the left, and the last row moves 3 to the left. The last part of permutation is mixed columns. Column-wise, apply linear transformation to each one of these columns. There is certain matrix, then multiply each one of these columns and it becomes the next columns. So, linear transformation is applied independently to each one of these columns. Shift row and mixed columns is very easy to implement in code. This slide shows the code size performance trade-off. If you allow no pre-computation, including computing the S-box, it would be a small implementation of AES and it could fit on the slowest because everything is computed on the fly. And if you use big table, it is so fast since just use lookup table and XOR. It's also good to know since AES is popular, Intel put AES support into a processor. It calls Intel Westmere. There are special instructions in Intel processor to help accelerate AES, as you can see in this slide. This slide shows the AES pseudocode. It should be mentioned that all the details about AES and pseudocode are provided in the documents. So you can write the program and find more detail in documents. Okay, the student must write a code that can perform AES 128 on an input string and write the result in a file. The template file is provided in the lab2 directory. Template file can read the key from a file. Students must implement the mixed columns in 2 ways. Lookup table and function, and compare the speedup of AES. They can follow lab 1 instruction to upload the template file in the Jupyter environment and then follow this instruction to compile and run their program. This slide shows how you can open a terminal. You can open the terminal from the launcher. This slide helps you to compile the code and run the application. Finally, to verify the program, we will provide an executable decryption program to check your encryption procedures. Thank you for watching. I encourage you to follow up with other videos, and there will be also a GitHub repository that provides all the codes.